Kia ora, 12 and 13. This is the first part of the 2014 complex numbers paper, so 3 easy questions from question 1 first. Alright, given that x minus 2 is a factor of this polynomial, find the value of p where p is real. So if x minus 2 is a factor, that means that g of 2 is equal to 0. So g of 2, just substituting in 2, is equal to 8 minus 2 times p times 2 squared, so minus 8p plus 2p minus 5, so that must equal 0. That gives us 3 is equal to 6p, p is equal to 0.5 or 1/2. Right, if u equals 3 minus 3i, find u to the power of 4. So u equals 3 minus 3i, we need to write that in polar form first. Here's 3, here's negative 3i, so u is down here. Now we can see from looking at that we've got an example of a special triangle again. So here's 3 and 3. So this is a triangle that's similar to 1, 1, root 2. This one will have a modulus of 3 root 2. And the angle in here is going to be negative pi on 4, which we can also write as 7 pi on 4. Okay, and I'm going to go with this form here. So 7 pi on 4 is this angle around here. So the first step is to write u equals 3 root 2 cis of 7 pi on 4. So u to the power of 4 is equal to that to the power of 4. So by de Moivre's theorem, 3 root 2 to the power of 4 is equal to 324. Cis, well, it's going to be 4 times 7 pi on 4. Right, because remember de Moivre's theorem says that if we've got r cis theta to the n, that equals r to the n cis n theta. Okay, so this whole thing equals 324 cis of 7 pi, but we don't want to leave it like that. So let's look again at my Argand diagram. 2 pi is 1 revolution, so we can take out multiples of 2 pi in there. So our answer here should be equals 324 cis pi. Now we were asked to give it in that form, so we're going to leave it like that. But cis of pi is equal to negative 1. So if I had to write it back in rectangular form, that would equal negative 324. Alright, on to part C. Now if that one wasn't feeling easy, it means you need to go over de Moivre's theorem and you need to go over your special triangles, because it's probably the other thing causing problems. Right, solve the equation x equals this. We need to get the square root sign on its own on one side, so we're going to go x minus 3 equals root 33 minus 4x, and now I can square both sides. But even when I'm on this step, I need to remember when I've got square root equations, it's very important that I check at the end that my solutions do actually make sense. So we're going to come back to that. So expanding, x squared minus 6x plus 9 equals 33 minus 4x. X squared minus 2x minus 24 equals 0. Very simple quadratic. I can get x minus 6 or x plus 4. So this is the first bit, and this is where we write down, as usual, that x equals 4 or x equals negative 2. X equals negative 4, but we have to check each of those. So I'm going to do that on a new slide. Okay, so in this last step, we've got our 2 possible solutions, and we need to check them. So what we want to do is look at our equation, the one we started with, which was the right-hand side was root 33 minus 4x plus 3. So we're going to substitute in our values, and we're going to see if we do actually get our x coming out. So first we'll try x equals 6, and that's going to give me 33 minus 24 square rooted plus 3. So let's look at that. The square root of 9 plus 3, 3 plus 3, which is 6. Okay, so x equals 6 is a solution. Now we're going to do the same thing with x equals negative 4. And we're going to see that it all goes bad. So 33 plus 16 plus 3, right, which is substituting that into the left-hand side, into that bit of the equation, gives me square root of 49. 7 plus 3 is 10, which is not equal to negative 4. So x equals negative 4 is not a solution. Alright, so that's the first three parts of that question. Part C is merit, and parts A and B are achieved. Thanks for watching.